All right, folks, we're back here for another lesson here. We're going to talk about lines of best fit, which goes directly with scatter plots. It's just our next little step with scatter plots. Our essential question today is how can I use lines of best fit to make predictions about data? So you might be wondering and asking yourself, Mr. Nowinski, what is a line of best fit? Well, here we go. All right. A line of best fit is a line that is very close to most of the data points in a scatter plot. So yesterday we looked at what the data points would look like. We talked about the trends that we would notice, positive and negative, linear and nonlinear. Today we're going to be making a line that goes directly with this information. Very close to most of the data points is almost like the mean or the average of all the data points. The thing about this is yours might be a little bit different than mine, and that's okay. It's just they should be around the same type of answer, okay? When doing this, it's a line, so we're going to have to use the old y. Ooh, what am I doing here? Y equals mx plus b. All right, we must remember our m is our slope, our b is our y-intercept, and we're going to use that for predicting data. All right. So there's a couple of steps that we're going to need to follow. We're going to use that note page that I put into Google Classroom. All right, that has a couple of examples here for us. So this is a scatter plot with no line of best fit, so we're going to create that. But before I do create it, a couple of things that we are going to want to be able to do when we are creating the scatter plot to make sure we're successful. The very first thing that we're going to need to do is we need to determine the correlation. So this is using what we did yesterday. Are we looking at positive? Are we looking at negative? What's going on? We're going to draw a line of best fit. I'll show you what that looks like here in the moment. We're going to identify our parts of our slope-intercept form. So we need to identify M and B. And then we're going to write a function in slope-intercept form. And then using slope-intercept form, I'm going to be able to answer questions based on the information by plugging those numbers in to the equation. All right, so the very first thing that we're going to look at here is hours of sleep and our test scores. So we have our data points all over the place. Hopefully when you're looking at this, you see that we have a positive correlation. That's our most important part. So I'm going to take a straight edge and try to create our line of best fit. It's obviously got to be a straight line. You know, I want about the same amount of points on top that I have on top and on bottom for this information, just so it's, you know, nice and good here. So it looks like here, I don't know, around. Sometimes you can kind of fiddle with it just to make it look good for your data. I'm gonna go right here. All right. So it looks like it's pretty much on par with everything here. So I can see right here is my y-intercept, 0.65. So then I need to determine our slope. All right, so right away I know it's going to be y equals something x plus, it's going to be plus 65. All right, now I got to determine the slope. Well, I'm just going to figure out my rise and run between some pretty good, easy points. And we're looking at points on the line. We're not looking at points, you know, between data points. You know, if I compare these two, well, that's obviously much steeper than, You know, those two look parallel to my line of best fit, but those aren't. You know, that might even be an outlier, but, you know, I don't know. I maybe need some more data points. All right, so I'm just going to look for nice, easy spots where we're going through some good corners. I always call it corners. So I see this is a perfect one, our y-intercept, and that one looks like a pretty good one right there too. So I'm going to count my rise over run. Looks like I'm going to go up 5, 10, 15, 20, 25. So that's going to be a rise of 25. And looks like it's going to be a run of 1, 2, 3, 4, 5, 6, 7. All right, 25 over 7. I can't simplify that. It's just like an ugly number. But that is my equation. Now, I can use this information to figure out, all right, what is going to be the test score if I get 12 hours of sleep? These numbers are our x. I plug in 12. I multiply, I add the 65. Then I can figure out what my test score is. All right? Or if I want a 100, I plug in 100 here and then solve the equation, figure out how many hours of sleep would I need based on the data. Is it a foolproof plan? Probably not, but it would work nonetheless for kind of what we're looking at. All right, so another example that we have on our note page is music sales from 1999 to 2009. We almost weren't even born here. All right, so this one kind of looks a little bit almost non-linear, but we'll kind of just go with it nonetheless. It's definitely a negative, so we identify that first. I think my line of best fit's right about here. I don't know. This looks about by the average here. I see my y-intercept here. Looks like 17. I'm going to find my slope. Try to find a couple of good lines here that we went through. You know, I could almost just go from like here to there. That looks almost fine to me. Looks like I went over 1 year and down 1 billion in amount of sales. All right, if I don't want to use that, I want to use like this. It looks like that trend might be kind of good as I look down here. So I can probably apply that everywhere here. So it looks like my slope is just going to be, since I'm going down or over 1, down 1 and over, it'd be negative 1 over 1x, and my y-intercept is a plus 17. So I can figure out how many years after 1999 we would have, what those music sales would be based on this information using this equation. All right, so if I want 15 years afterwards, so this would be, looks like it's 11 years here, 99 to 09, so 4 more years would be 2013. All right, what are the music sales in 2013? That's 15 years from that point. I plug it in for X and solve and figure out it's around about $2 billion in sales. Would it continue on that trend? Probably not, because then you're saying they're making no money, but it is what it is. All right, our last one here, our last little example, business growth. Definitely a positive. We can see our data going this way. I'm going to go, right about here, I'd say. Again, just depends on what you see. All right, but it should be pretty close and similar to one another. So it looks like to me, my y-intercept is right here at about 20. Looks like my rise, you know, it looks like it's up 10 and it looks like it's over about 5. All right, so my equation here would be y equals, I said up 10, and then I look at my intervals, so that was 5 here, so 10 over 5, x plus 20, which really is just y equals 2x plus 20. And I can kind of say, all right, after how many days, maybe after 50 days, you know, how many customers are we going to have in there? All right, 2 times 50 is 100, plus 20 is 120. Yay, 120 customers, but not during a pandemic, probably. All right, so that's what I got here. There's some additional examples on page 131 and 132 in your packet. Go ahead and get started on those. Check the Google Classroom for what is being specifically asked of you. Today, you will not have to submit anything with a picture or anything like that. We will have to do that as time goes, but not today. So make sure you just answer those questions and make sure you're thorough. Don't be skimpy with your answers. Be thorough with what you're trying to tell me. Yeah. If you have any questions, you know where to find me. Ooh, did I remember our movie quote? I didn't think I remembered a movie quote today. The movie quote for today is, "You're killing me, Smalls." All right. Have a great day. Peace.